Hi and welcome to another maths video. In this video we are continuing on from the previous video where we looked at the definition of a function and we looked at the domain and range of a function and we looked at the inverse function. So I'll just quickly recap what we did. We said that if we have a set, let's just call it 1, 2, 3, and we'll call that set A, and we'll say set B is equal to, let's say, 2, 4, 6. Then if we link elements in that set, then we've created a relationship. So long as one element from one set links to one element from the other set, then that relationship is a function. And we drew a function as like a box with an input and an output, and for example we might call that function f of x, and we take the entire set A as the input and we call that the domain, and if we have the entire of set B as the output, then set B is the range of the function. And we also said that we can create an inverse function, and we use this notation with a little -1 above the f, and then that's just basically the exact opposite. So we have the range of the original is the domain of the inverse, and the domain of the original is the range of the inverse. And we can link them together, and so we can say this is so if we put x in, and let's say x is 1, then x goes in, f of x turns the 1 into a 2, then the 2 goes into the inverse, and the inverse turns it back into the 1 again. So whatever the argument is for the original function, if you then put the output of the function into the inverse, you will get the original argument back out. So f to the -1 of f of 2 would equal 2. It's just that simple. And this brings us up to compound functions, where we can use a function as the argument for another function. So let's try and work through a few compound functions. Let's define f of x is equal to 2x plus 1, and let's define g of x is equal to x squared, which is a fairly common one. You might see this exact question on an exam paper, and you might be asked to find f of g of x. And some people might write it f o g of x. Both notations mean exactly the same thing, and there's only the one bracket. There we go. So both these notations mean the same thing. So we take the g of x as the input for the function f of x. So g of x is equal to x squared. So f of g of x is equal to f of x squared. and f of x is 2x plus 1, so we just write whatever's in these brackets, whatever this argument is, instead of the x here. So that's f of g of x is equal to 2x squared plus 1. Now we could also ask, what if we tried to do it the other way around? For example, what is g of f of x? Well, f of x is 2x plus 1, so this is equal to g of 2x plus 1. And g is just x squared, so we take whatever's in the brackets and replace that with the x, so that's just 2x plus 1 all squared. And that's all there is to it for compound functions. So let's try and see if we can find the domain and range of compound functions. In fact, let's do the same thing for the one we did before. So f of x equals 2x plus 1, g of x equals x squared, and let's do f of g of x, which is equal to f of x squared, which is equal to 2x squared plus 1. Right, so the domain and range of 2x plus 1 is just a straightforward linear equation, no problems there. So the domain is all real numbers, and the range, again, you're going to get any value for x, is all real numbers, no problem there. With x squared, the domain again is all real numbers because you can square anything. However, a negative times a negative is a positive, so our output will be only positive numbers. Or all real numbers such that x is greater than or equal to 0. Right, so what then is our domain and range of this? Well, to find this, we really probably want to graph it, don't we, to see exactly what's going on. X can be anything, right, so anything can go on the x-axis. Now, if x is 0, then we're going to have 1. If x is negative 1, negative 1 squared is 1, 2 times 1 is 2, and 2 plus 1 is 3. So if x is 1, then we're going to have 3. And if x is negative 1, again we're going to have 3. Now if x is less than 0, x squared is going to be more than 0, so the smallest this value could ever be is when x is 0. So this 1 here is our minimum point, and because it's a quadratic equation, it's going to be vaguely parabola shaped. It's going to be like this U-shaped, because this is, the 2 here is positive, so it's not going to be a negative N-shaped, it's going to be positive U-shaped. So our graph's going to look a bit like this. So our range is going to be all real numbers such that f of g of x is equal to or greater than 1, and the domain is all real numbers. So our domain is all real numbers, and our range is all real numbers such that f of g of x is greater than or equal to 1. There's no way it can ever be less than 1, because 2x squared can never be less than 0. Okay, I think that's going to do it for this one. In the next video, I'd like to look at the domain and ranges of a few more functions and introduce the concept of adding, subtracting, multiplying and dividing functions. So I will look forward to seeing you in the next video.